Oh my god. It's killing my OCD soul.
Hi there guys, I'm Chris Boden. Welcome to... Jesus fuck, I gotta clean that line. It's just not fucking acceptable. On YouTube for a living now. Oh, that's way better. Oh yeah. Oh, Christ. Oh. Put the extra one back in there. Yeah. Let's try that again. Hi there guys, I'm Chris Boden. Welcome to Ow, you motherfucker! Jesus, that fucking hurt. Oh my god, we gotta... There's so much clutter. I can't even. I can't. Fuck, that hurt. I'm gonna die. I'll never walk right again. Fuck! Hi there guys, welcome to today's Captain's Blog. I'm Chris Boden and you're not. So, I want to give you guys a little update. I've been doing electronics videos because I can't do robot videos at the moment. There's a robot, he's hanging out over there, and the other two. But I've got it. Fuck. So, and the reason for all this is I gotta watch where I walk or I'm gonna fucking die. Oh my god. The reason is I've been working on this, and in order to get this room up and running and good, so that, because like, look at how bad it is. It's completely fucked. Everything's packed in there. And the reason it's all packed in there is because we're in the middle of remodeling, and I'm trying to run my business, Moose trying to run her business, and the AV team's trying... Oh my god, you gotta see the AV room. See, they're all fucked up too. So there's just... Here's yeah, they've got shit all gunged out. Yeah, it's a vinyl cutter in here. So, yeah. So I'm doing electronics videos for the week, just so that you guys can have something to see. I wanted to hop on real quick, because I gotta make a video. That is so fucking cool. I'm so proud of that. I wanted to make a quick video for a good friend Parker, who's having some problems, and I wanted to show stuff on Transformers, and that's easy to do. All I gotta do to do a really good video on Transformers is grab my big ass power supply and my Axie draw, and I can, you know, some test equipment, and I can just show him some shit, and I can talk about Transformers. But it's fuck! So, we're gonna have to do this the hard way. We're gonna have to talk. Parker, we need to talk. So, Parker, here's the thing. The way Transformers work, you started with a 15,000 volt neon sign transformer. Now those have 3 windings in. You've got the main center winding, where somehow you counted all the turns, and I still don't know how the hell you did that, but I'm just gonna take your word for it that you counted all the turns, and that you removed like 40 or so turns, and by reducing the primary to secondary coil ratios of the number of turns in each, yes, you did raise the voltage, but at a cost. Now the other thing you said you did is you talked about this twice, and in one point you said you reversed one of the secondary windings, and the other one you said you took them both off and reversed them, so I'm not really sure what you did, but it doesn't really matter. Let's talk about how Transformers work, specifically neon sign transformers. On the NST you had, what you had originally was a main center winding and then 2 secondary windings. The center winding is called the primary, and the 2 little windings on the outside are called secondary. Now, each of your secondaries on a 15,000 volt neon sign transformer, each of the secondaries is a separate transformer, kind of, that they're center tapped. So one end of the secondary connects to the main frame, the ground, and the other one gives you 7,500 volts. Now, the 2 windings, one of them is reversed, so that when this is at 7,500 volts high, at that instant, this one is at 7,500 volts low. So, if you flipped them both around, you still had 15,000 volts, okay? If you flipped one around, you have 7,500 volts, or 0, depending on how you did it. You also said you disconnected them from the center and hooked them end to end. So, your options here, because you have 2 7,500 volt transformers, your options here are, you have, depending on what you did, and I'm not entirely sure just what the hell you did, but you could only have done one of 3 things. Either you have 0, 7.5, or 15,000 volts. Those are your only 3 options. Now you're gonna have a little bit more because you took off some of the primary wind, but not a lot more. And you certainly didn't get 60,000 volts. And the reason that I know absolute, and man, be scared of anybody who speaks in absolutes, because whenever anybody tells you, I have found the truth, they absolutely have not, and run like hell away from them and hold on tight to your wallet. But this is engineering, and you have a decased 15 kilovolt neon sign transformer, and you think you have 60,000 volts. You don't. You can't. You can't. And the reason is breakdown voltage. If you tried to put a differential of 60,000 volts across any part of your secondary coil system to any other part of that transformer, the secondary, the anything, you're gonna get a lot of smoke, fire, heat, and then you're gonna ugly cry for like an hour. To design and build something for 60,000 volts is a monumental pain in the ass. Epic pain in the ass. It sucks. I know because I've had to do it several times. Once you get over 20,000 volts, things get really hard. And when you're up at 60,000 volts, things are really hard. And you're dealing with a lot of oil and huge air spaces and crawling breakdown and creepage distance and just all kinds of stuff going on. It's a monumental pain in the butt. There is no way in hell your transformer is outputting 60,000 volts. Not with what you have. But you did get a good clue. The way transformers work is through a process called magnetic flux. Okay? If you ever, and you can try this, you can experiment with this. If you ever get a thing of the magnetic viewing film and you hold it on a magnet, you'll see the lines. If you ever play with iron filings in a magnet, you'll see the lines. Those lines are flux. Now let me tell you what the flux, because you can only fit so many of those lines of flux into a given iron core. There are tricks, lamination, stuff like that, to help with eddy currents and make those line up. There are some tricks you can do with laminations and stacking and I cores versus E cores versus C cores, and there's stuff you can do. But you can't work fucking miracles, man. Physics wins. Entropy wins. The second law of thermodynamics is a complete bitch and has no forgiveness at all. So once you try and put in an electrical system, when you bring up the power a bit, you add more lines of flux. Cool. But how many lines of flux you can get in total is dependent on a lot of things. It depends on your voltage, your current, your core itself, the shape of it, how it's made, what it's made of. There's a lot of different things you can make cores out of. They don't all have to be steel. Check out the ferrite, powdered ferrite stuff. And it depends on your windings and all kinds of stuff. And once you get your maximum number of lines of flux, that's it. It's called saturation. And once you've saturated it with as many lines of flux as you can get, doesn't matter what you do, you can't fit any more in. What you will do is have a whole lot more power you can dump into it. You're just not going to get anything out of it because it isn't going anywhere. It's just turning into heat. Entropy reigns, man, and heat's the bitch. And what's going to happen is as you crank up the knob, the lights will dim in your house because you're cramming way more amps in, more current that's just turning into heat. You're not getting anything out of it. So you can't directly compare input power, input voltage, input current to the output because they're not going to match anymore. They will at the start. That's why we use transformers. Whether it's a current transformer or a potential transformer, that's why we use them, because we know if we put this in the front, we're going to get this out the back. But there's a point, and that point is saturation, where you just, the input will just go whoop, and the output's just going to, and these two things will diverge really hard, really fast, because you've saturated it. You'll dim the lights, you'll burn a fucking house down before you get any more power out of that transformer. It's just going to melt down. It's not intuitive though, because what you were taught when you first started learning about transformers doesn't make sense now, because you've crossed a line. You've done something different, and it's not obvious and it's not intuitive. And a lot of us that experiment in high voltage fall into traps like this, and you will fall into more. I have, all of us have, Antonio has. You don't know what you don't know, and what you don't know is a lot. I've been playing with Tesla coils and high voltage for a couple years now. There's a couple videos on the internet, and I've built some Tesla coils and I've played with some stuff and I've learned some things. I've made mistakes. We all do. I burned a whole lab down once. You will make mistakes, and that's okay. But learn to check everything. A lot of people on the internet aren't very forgiving. A lot of people on the internet are actually pretty mean. I'm kind of a dick myself. But when you say things like that, when you say, I have a neon sign transformer that's designed for 15,000 volts and I'm getting 60,000 volts on it, the first thing that guys in my world say is, extraordinary claims require extraordinary evidence. Is it possible to get 60,000 volts out of a neon sign transformer? Maybe, with a lot of engineering and a well-stocked lab and people that really know what they're doing and some very expensive tools. Yeah, maybe, perhaps. It'd take a lot, but unless you hook a probe up to that and measure it, and you know your meter's right, and you know everything's calibrated, and everything's just right, and you're wearing clean underwear, and you've got your safety glasses on, for real science, unless you can prove it, unless you can measure it, it didn't happen. I'm going to jump out on a limb and speak with absolute certainty, and no generality at all, and say, there's no way in fuck fuck, you got 60,000 volts out of a 15 kilovolt NST. No, you didn't do that. You think you did, but you're wrong, and I explained why. Now keep fucking with it. Keep learning, keep experimenting, because you fell into a hole in your knowledge, and we all do. But you'll get better, you'll get smarter. We did. And if you're lucky, you'll survive it, because you're going to get bit, you're gonna zap yourself, you're gonna set the carpet on fire, you're gonna get yelled at, you're gonna waste money and a lot of time on various projects, but keep doing it. Because it's how you get smarter. It's how you get better. It's how you build amazing stuff and put it on the internet, and that's what we're here for. You're doing fine, kid. Just keep doing what you're doing. Have fun. I'll see you guys next time.